This video is going to be for Ivy Tech Community College. We're going to be looking at homework 1A, problem 9, which is also referred to as problem 3.06. What we're going to see here is the vector. We've got two vectors. The first one is 6.3 units long and points along the negative x-axis, and vector 2 is 8.7 units long and points at 50 degrees to the positive x-axis. So part A is asking here, what are the x and y components of vector v1? Since this is laying along the x-axis, the full length of it, 6.3 units, is going to be the x component, and it's going to be negative since it's pointing in the negative direction. The y direction, it doesn't go up or down, so it's just going to be 0. Now, what are the x and y components of the second vector? Well, the second vector here, as is mentioned, is 8.7 units long and points at 50 degrees to the positive x-axis. So to find the x component, you take the full length of that vector and multiply it by the cosine of the angle, 50 degrees in this case. For the y value, you take that same component or that same magnitude and multiply it by the sine, and that will produce the 6.7 units. Now, to give you a graphical here, we've got, and you can do this here at the same website if you wish. Our first vector here is 6.3 units and follows along the x-axis. The second, if you type in the information that we have here, the angle that it makes with the positive x-axis, and then the magnitude as well, then you can see the x and the y components here. So we've got our first vector here, we've got our second vector here, and so we can see what it is that's going on. Now, we're going to move on to part C, and we're going to determine the magnitude of the sum of those two. Now, the sum of those two is going to be this plus this. So it's going to be the vector that connects those going from tail to tip. And so this is going to be V1 plus V2. How do we determine the magnitude of this? We're actually going to use the law of cosines. And I don't know if you have ever seen the law of cosines, so let's go ahead and let's look that up. Law of cosines. And you can see here that the length referred to here is going to be based off of this length, and this angle. So if you have all of that information, you can fill all of that in and you can determine the value of C. So you can see here that's exactly what they've done. And they come up with 6.7 units. Now, does that match what this has determined? And as a matter of fact, it has. That's what it's telling us. On top of that, how do we determine the angle of this particular sum with respect to the positive x-axis? In other words, this stuff over here. We know it's a little bit past 90 degrees because we can see the y-axis here. The question is by how much? What you can do is you can take this vector right here, draw a right triangle, and you can find this particular angle by finding the x and the y components. How are these x and y components determined? Well, to determine the sum of the component vectors, if you add those up, you find the x value here and the y value here. Now, we know that the tangent of this particular angle is going to be the y value divided by the x value. When you do that, what you come up with, and let me clear this out, what you're going to come up with is actually going to be 6.66 divided by minus 0.70775. And you come up with this. Once you take the inverse tangent of that particular value, you come up actually with something close to 83. And then once you add 180 to it, then you end up with 96. So let's kind of work through that step by step here. I'm going to clear everything out. Looks like that. So, okay. All right. So let's try this again. 6.66459 divided by 0.70. What's the rest of it? 775. That needs to be negative. So we've got that. And let me pull this down a little bit so you can kind of see that. And now I'm going to use the trigonometric function. If I use the inverse tangent, I find out that that is 83.93. What that's referring to is the angle here that's inside the triangle. Now, if I want to know what the angle it makes with the positive x-axis, not this axis, but this over here, I have to add 180 degrees to that. When I do that, I come up with 96.06. Now, as it turns out, that's exactly what it's telling us here. It's 96.06. So I hope that helped out a little bit, and that if you have any questions, please do let me know.